In this video, we're going to talk about how you evaluate definite integrals, and then I'm going to give you a couple examples to try, and I'll show you my work. If this video helps you, please like and subscribe for more calculus help. I have entire playlists on Calc A, B, and BC. All right, so to evaluate a definite integral, and by definite integral, I simply mean that it has bounds. We're trying to find the area under this parabola between x equals 1 and x equals 3. You can always tell which axis it's working off of by the d somethings. In this case, these are x's. First thing we do is find the antiderivative. In this case, it's just power rule. We're going to raise the power and divide, and then raise the power and divide. We already had a 3 out there, so it'll be 3 halves. We're going to evaluate this at 3 and 1. So if I plug 3 into my function, always plug the top bound in, 1/3 of 3 cubed, so 1/3 of 27 is 9, plus, and then we have 3 halves of 3 squared, so 3 halves times 9 is 27 halves. Then we plug in 1, so we have 1/3 plus 3 halves, like that. Okay. So if I'm thinking like a common denominator, I guess, with all of these would be 6 between everything. So maybe 54 plus 81 all over this over 6, this over 6, minus 2/6, excuse me, minus 9/6. So we have 145 minus 2 is 143 minus 9. We have 134 sixths. You could also use your calculator to do that, but this is our way of doing a definite integral. Find the antiderivative and then plug in the top bound and subtract, plugging in the bottom bound. All right, here are 2 examples that I would pause the video and try. Let me show you my solutions again. If this helps you, please like and subscribe. All right, so we need the antiderivatives. Antiderivative of sine is negative cosine. Antiderivative of cosine is sine. We're going to evaluate at pi and 0. Well, if I plug pi into cosine, I get -1, but I already have a negative in front, so 1. And then the sine of pi is 0. If I plug 0 into cosine, I get 1, but of course it's negative cosine, so -1. So I end up with 1 minus -1. The answer is 2. And then the antiderivative of 1 over x is natural log of x, evaluated at e squared and e. I'm going to write e to the first. Well, the natural log of e squared is just 2. And the natural log of e to the first is just 1, because natural log and e are inverses of one another, so they undo each other. So it ends up just being 2 minus 1. It's just 1. Again, if this helped you, please like and subscribe for more calculus content.